So hello everyone, we are back again now with part 11 of the video from the chapter Light, Reflection and Refraction. And today is the part where we'll discuss the questions and numerical based on spherical mirrors. So let's begin. The first question which is related to the spherical mirror is question 7. We are talking about the end of chapter questions from the chapter Light, Reflection and Refraction. It's a CBSE chapter and we are on page 186. We are talking about question 7. So before we go ahead solving with any of the physics numerical or physics question, it's very important that we read the question carefully, because many a time it happens that when you read the question carefully, question becomes very clear, and what should be the answer also becomes very clear, because many a time we feel by looking at the length of question we avoid solving physics numerical. So let's see whether this is a numerical, is it a question, is it a ray diagram. It's basically a 3-mark question. Let's see how to solve it. So first thing, as I told you, is reading the question carefully. So it goes like this: we wish to obtain an erect image of object. So from this only we should get an idea. We want to obtain erect image of an object, which means virtual image, and it says using a concave mirror. So when we talk about concave mirror and virtual image, there is only one situation, that is when the object is between pole and focus. Half of our question is done. Of focal length 15 centimeter. Now the question says focal length is 15 centimeter. We are provided with focal length 15 centimeter. It says what should be the range. Please be aware, the question is asking for the range. It's very important that we look at the question carefully. Range of distance of object from the mirrors. And it's not asking in terms of a single digit answer. It's saying what is the range from where to where we can place the object. So because we know that in concave mirror there is only one possibility where we can put the object and we get the image which is virtual, and that is between P and F. So because focal length is given, so the range in this situation is going to be between 0 and 15 centimeter. Now this word between is very important. You don't write this, you get 0 mark, because if you say range is 0 to 15, that means 0 and 15 both are included. If you say between, it means 0 and 15 are not included. It is in between 15 and 0. So anywhere between 0 and 15, if you place, that is between P and F, you will get the image which is virtual. And if it is virtual, the next part of the question says what is the nature. So it is virtual, so it is erect image. And is it also smaller or larger than the object? So we know the image formed in this situation is going to be larger than the object. It's magnified image. And the next part says draw the diagram. So we will draw the diagram, which is diagram for the case when the object is between P and F. So let's have a look at the standard answer from the reference book or one of the website. And this is the answer. It says a concave mirror gives an erect image. So look at it carefully. Erect image when the object is placed between focus and pole. From this line only we have got all the understanding of what we were discussing of the mirror. So answer has to be between 0 and 50. I'm emphasizing again on this word, which is between. You don't write this, you get 0 marks, because there is no validity if you say range is 0 to 50. The image thus obtained is virtual, erect and larger than the object. And this is the diagram where the object is between P, which is pole, and as per our discussion, this was our case 1, but as per your textbook, it is case 6 of your ray diagram. This was question 7. Let's go to question 8. Question 8 is basically a theoretical question. It says which type of mirror is used in following situation. So for headlight, we use the concave mirror, because in concave mirror we have the headlight, the bulb is here, the light is going from here and it's spreading in the all directions. So this is the situation where the object is at focus. So we use concave mirror. In other case, when we are talking about rear view or side view mirror, we want to observe larger area. So we have larger area, we will be able to see greater area, and everything will be erect only for us. So that's why we use the mirror which is convex mirror in case 2. That's uh, question 2. That is 8b. Now solar furnace is exactly opposite of 8. Object is at infinity and we keep the food or material which has to be heated at focus so that it gets heated up fast. So this is basically the situation where the object is at focus. This is the situation where the object is at infinity, and this is the case where we are talking about a convex mirror. Object is kept at a finite distance. So let's have a standard answers also. So it says concave mirror are used as a reflector in headlight of cars. When a bulb is located at the focus of concave mirror, the light ray after reflection from mirror travel over a larger distance. So as I told you, so if this question comes up with a statement asking you to draw ray diagram also, then you will draw the ray diagram of the situation where object is kept at focus. We should understand that, and then only we'll be able to draw. So then in that case, it becomes this is 1 mark and 2 marks for the ray diagram. Second part goes like this: side view or rear view mirror of vehicle. Why we use convex is because it always forms, we can see it always forms the erect image which is diminished, and always we can see it's virtual also. Second part is it has a wider field of view, so we can have a wider look at what is behind us when we are in the vehicle. The last one is solar furnace. Again, we are using concave mirror because it can concentrate, it's a converging mirror, right? So all these three sub question of the question 8 could individually be a 3-mark question. By which mirror and draw the ray diagram. So for this, it is object at focus, this is object at infinity, and this is object at finite distance in convex mirror. This was question number 8 from page 186. Now the next question from the textbook is question number 12, which is a basically numerical. So let's have an understanding of numerical. In numerical, we need to understand what is given first, and then other things we know the formula, we know how to substitute and get the answer. So only thing important, which if you miss it, you miss the whole link and you'll straight away get 0. So it's very important that you understand what is given. So let's understand. An object is placed at a distance of 10 centimeter. Object distance given in the question, which is 10 centimeter. We know object distance is represented by u. Now, as we have discussed in one of our previous video of sign convention, it's there in the I button also, the video on sign convention, that whenever we are talking about sign convention in numerical, we have to use them. So object is always kept on the left side. So object distance is going to be -10. It says convex mirror focal length given to us 15 centimeter. Now we know as per sign convention, focal length of convex mirror is positive. It's positive 15 centimeter. Question says find the position, which means you have to find V. Nature, position and nature. For finding nature, we have to find out M. From M, we will also get the magnification and we will also get the nature. So there are only 2 formulas which is to be used. So whenever you're solving numerical, please follow this pattern and this will help you in getting a good score. So first thing is writing the formula. What is the formula? 1 by V plus 1 by U equals to 1 by F. From this formula, when we substitute, we will be getting the required answer. And the next formula is M equals to minus V upon U. You just write this much. If it's a 3-mark question, you get half mark for this formula and half mark for this formula. And rest all substitution we'll see in the solved numerical as per the book. So let's have a look at it. The formula, as we have discussed, what is given in the question, this was our formula. 1 by V plus 1 by U is equal to 1 by F. So we'll just substitute. Don't forget, for substitution also you get marks. So after putting this value, let's substitute. We have got focal length is plus 15, object distance is -10. You can see the symbols are not being changed just because there is half mark for substitution also. And then we will do cross multiplication. You can see, or we can take LCM also, and after taking LCM we are getting this answer, which is 1 by 6. V is equal to 6 centimeter is our answer. So when I say V is equal to 6 centimeter, we are getting positive value. Positive means it's formed on the right side. So from this also we understand that the image formed is virtual image. Now we have to find out whether it's magnified or diminished. Although from our ray diagram only we know that the image formed by convex mirror is always going to be diminished, but let's prove it. we'll use the magnification formula, m is equal to minus v by u, and v we have just now obtained minus 6, minus is already there, so 6, and u is minus 10, so we get plus 0.6. So as per our convention, we know the answer for magnification is coming out to be 0.6, which is basically less than 1, and from this we understand that the image formed is diminished, and from this we can say that the nature of image is virtual, erect, and diminished. So this is your 3-mark answer. For writing the formulas, you'll get half of mark each. Substitution, you'll get half of mark each. Getting the correct answer with correct unit will give you half of mark. So basically this is your final result. So please make sure that you are writing the formulas correctly, even if you don't want to solve it, or if you are not clear about how to go ahead. Although you should be clear now after this video. Let's go for the next question. This was question 12 from page 186. We'll go to the next question. Next question is again a question based on convex mirror. So let's have a look at the question and let's see if we are able to understand what's given in the question. This time it says an object 5 centimeter in length. So when we talk about object length, it means we are talking about what is given. We have height of object, which is 5 centimeters. So as per our sign convention, we know height of object is always positive. Is placed at a distance of 20 centimeter. So object distance is given, which is 20 centimeter. Now again, as per our sign convention, object distance is always going to be negative. Going ahead, it says it's placed in front of convex mirror of radius of curvature. Small twist here, it's not focal length, it's radius, and it's of convex mirror, so it's going to be 30 centimeter, and because it's convex, so it's positive. It says find position of image, which means we have to find v, and it says find nature and size, which means we have to find magnification, and we also have to find size of image, which means we have to find height of image as well. So half of your work is done. After that, we have to just use the formula. The formula is 1 by v plus 1 by u equals to 1 by f. And for magnification, we use the formula minus v by u. As I told you, writing the formula will give you half of mark each. Your 1 mark is sorted. Let's see how to solve it. Before we solve it, here focal length is not given. So we know in this case, there is going to be another formula, which is for finding out the focal length. So let's see what is the focal length. We know r is 30 centimeter. So from this, we can say that therefore focal length is equal to the radius of curvature upon 2, which is plus 30 upon 2, which is plus 15 centimeter. So we've got the focal length as plus 15 centimeter. Now some of our students also have a doubt about how to substitute the value. So I'll be showing you that also, and then we'll go to the standard answer, which is there on the next slide. So the formula is 1 by v plus 1 by u is equal to 1 by f. So we will have to find, in this question it says find image distance. So it becomes 1 by v equals to 1 by f minus 1 by u. Now we will just substitute the values. 1 by f, focal length we have got was plus 15. So let's write it as plus 15 minus 1 upon u. U given in the question is minus 20 centimeter, if you can see. So just write this. As I told you, half mark for just writing the substitution. And now how to go ahead, either you can take LCM or you can do cross multiplication. Let's do cross multiplication also and see if we get the answer. It comes out to be minus 20. It goes here on the right side. It becomes minus 15 upon 15 into minus 2. So on in the numerator we have minus 35, and in denominator we have 15 into 2 is 30, which is minus 300 basically. So this is basically value of 1 by v. So if I'll just see if we can see minus minus gets cancelled. This is 5 into 7 gives us 35, and this 5 into 6 will give us 30. So this becomes 60. Therefore, now here since 1 by v, I can see since 1 by v, we are getting it as 7 by 60 positive. So what is going to be v value? Therefore, v is going to be 60 upon 7. Usually students forget this, and After solving this, we will get 8.56 centimeter. 56 centimeter. Now this is the value of V which we are obtaining, and you can see the answer again is positive, which means in this case also we are getting virtual image. So we know convex mirror always forms a virtual image, and we know from the ray diagram that the nature is going to be diminished, virtual, erect, but still we will find out the magnification, and for that we'll move on to the next slide. So let's see. You can see just now we've got 8.55 was the answer, and which if you round it up, it comes out to be 8.6. So this is our answer for image distance. Now magnification is basically minus V upon U equals to H2 by H1. Now the question says find the height of image also. No, so we will, on rearranging, we get this, and after substitution we get the answer which comes out to be 2.15. Ideally you should not round it up to 2.2. Even if you leave it at 2.15, this is more than sufficient. Usually whenever you're getting the answer, please get the answer up till 2 digits after decimal. So if it is coming at 8.56, leave it like this only. If it is coming as 2.15, leave it as 2.15 only. There is no harm, and in the end you can write your answer. This statement is very important. A virtual erect image of height 2.2 centimeter is formed behind the mirror. Now why are we saying behind the mirror? Because it's a virtual image at a distance of 8.6 centimeter from the mirror. This was your question. Again, this question comes for 3 marks. Now these were the questions related to convex mirror. Let's go to the next question, which is the last question on the spherical mirror, again on page 186, question number 15. So till now we were solving question which were talking about convex mirror, and now we'll go ahead for the question which is on concave mirror. So it says object of size. Now whenever you see object of length, object of size, it means it's height of object given. So first thing we'll do is write down given. Height of object given is 7 centimeter. So height of object always remain positive because the object is always kept above the principal axis. Going ahead is placed at 20 centimeter. So object is placed, which means object distance is given to us, which is 27 centimeter. Now when it is object distance, it's going to be negative because object is always kept on the left side. It says concave mirror of focal length 18 centimeter. Now focal length of concave mirror is given to us, which is 18 centimeter. Until now we were doing convex mirror, this time it is concave mirror, and we know concave mirror focal length is negative because focus is on the left side. Question says what distance the image will be formed. Now question is not directly asking you what distance the image is formed. It says at what distance from the mirror should the screen be placed. So when you are placing the screen, on the screen we'll get the image, so it means you have to find image distance. It also says find size and nature, which means we have to find height of image, and we also have to find magnification. So we will be using the formula. As I told you, first thing we will be doing is write down the formulas, because writing formulas gives you straight away half of mark each. So 1 by V plus 1 by U equals to 1 by F, and magnification equals to minus V by U equals to H2 by H1, because we will be finding height of image as well. So let's substitute and let's see what answer we'll get. We'll directly go on to the next slide, which has the answer also. So you can see here all the substitutions are done in the answer here. The formula is 1 by V plus 1 by U equals to 1 by F. That's the formula. So when we substitute, we have to find image distance. So when we'll take it on the left side, 1 by F minus 1 by U equals to 1 by V is our formula, half mark for this, where now we will just substitute the values. As we have seen, focal length is minus 18, object distance is minus 27, and minus is already there, so we will take LCM. LCM is 54, and after doing multiplication, finding out the LCM, we get minus 3 plus 2 upon 54, because both are minus minus, so we'll get minus 3 plus 2 is 1 upon minus 1 upon 54, which means we are getting the answer of image distance as minus 54. So see here, previously we were getting V as positive, which was indicating image is formed behind the mirror. Now this time we have got V as negative. It means image is formed on the same side where the object is kept. It means image is real image. So let's see, the screen should be placed at a distance of 54 centimeter on the object side of the mirror to obtain the sharp image. Going ahead, when we are talking about magnification, formula for magnification is h2 by h1, h dash upon h equals to minus v by u, and when we substitute minus v we have obtained, which is minus of minus 54 upon u is minus 27 into, when we are talking about h1 is plus 7, so this is plus 7. So we just know this is basically 2 minus 2 into 7 gives us minus 14. So again you can see here height of image is coming out to be minus. It means image is obtained below the principal axis, and from this we understand that the image is inverted, real. And why are we saying enlarged is because see the image height 14 centimeter, object height 7 centimeter, and from this we understand that the image is having greater size than that of the object, and from this we conclude that image is real, inverted and enlarged in size. These were the numericals which are there related to the concept of spherical mirror. With this we have also completed the concept of reflection of light. It's a huge chapter and we have completed basically the reflection part from the chapter, and we will be going ahead and discussing the next section of the chapter, which is light, basically refraction of light. So in the next video, which is going to be part 12, we will be starting with the basics of refraction of light. I hope you have enjoyed the journey of this 11 videos where we have discussed the reflection of light in detail. I hope you have liked and you have understood something about the concept. Also, do put your responses in the comment box, and if you have any questions, do put it in the comment box. That's it from my end. Thank you and have a great time. Bye bye.